Here we go, section 6.3. Here we talked about binomial and geometric random variables and just dove right in. In order for a situation to be a binomial setting, we check the acronym BINS, B-I-N-S. So what does that mean? B is binary. You're going to have two possible outcomes, the probability of success and the probability of failure. Let me try to tighten this up here so it's a little crisper. All right, independence. Each trial has to be independent. Number. You have to have a fixed number of trials, and S, the probability of success, has to stay the same. If all of those are met, then we have a binomial setting, which means we're going to have a binomial random variable. Binomial random variable on your formula sheet is here. It has two parameters, number of trials, probability of success. We're going to eventually get into this formula, the mean, the standard deviation. These formulas are on your formula sheet. Know that they're there for you. So in this question, they just ask you to go through, does this satisfy BINS, yes or no, be able to do that and just check. If any one of those four, not conditions, like criteria is not met out of BINS, then it's not binomial. All right. So we got to calculate a couple of different things when we got to binomial. And let me come up with a specific example to help us with this. So say the probability that someone is right-handed is about 90%, and we do a simple random sample of 5 people. There's a couple of questions you can ask. All right, what is the probability exactly 2 of the 5 people have or are right-handed? So in this scenario, let's check BINS real quick. They're either right-handed or they're not. Each person being right-handed has no impact on the next. There is a sample of size 5, fixed number. And success. The probability of somebody being right-handed is 90%. That's not changing. So the probability of exactly 2 is this. So that means I need 2 successes. Each trial is independent, so 0.9 times 0.9, so right-handed and right-handed. And I need the other 3 people to not be right-handed. Now, there's a couple different ways this can happen. The first 2 people could be right-handed and the last 3 left. It could be like the first and the third, and so on and so forth. Every single one of these scenarios has this same probability. So I need to figure out how many scenarios or combinations there are. To do that, I'm going to take my number of trials, 5, choose 2. I'm looking for 2 successes in each trial. This right here is this formula. These parentheses, that just means n choose x, 5 choose 2. Then we go to the calculator for this. You could plug this in as is, or you could do binom PDF, n equals 5, p equals 0.9, x equals 2. And that will give you your answer. Other things that they can ask here, they could say, what's the probability of at least 1? Oh, hey, we've done this before, but I'm going to show you a different way now. At least 1, so 0, 1, 2, 3, 4, 5, that would mean 1 or more of the people is right-handed. So that means I'm going to have to do 1 minus the probability of 0. So 1 minus the probability of none being right-handed. So this is going to be 1 minus binom CDF of, now it's CDF, cumulative, n equals 5, p equals 0.9, x equals. Basically, I want to subtract away the 0, leaving me with the 1, 2, 3, 4, 5. So I'd put x equals 0 here. That gives me the probability of 0. Say this whole thing here is 12%. This is 12%. This is the complement. That'd be 88%. I'm making that up, but the 1 minus that will give me the 88%. And the final scenario you might see is, let's say it's at most 3 or less. And x is the number of right-handed people. This would just be binomial CDF, n equals 5, p equals 0.9, x equals 3. Because now what this is doing, CDF is going to add up everything up to and including that number starting at 0. So 0, 1, 2, and 3. That's going to add up those probabilities, which is exactly what we want. And whatever that is, it is. So that's how to calculate your different probabilities for binomial random variables. All right. Yep. All right. Then we got into finding the mean and standard deviation of a binomial random variable. Pretty basic. The mean just has that formula n times p. I'm checking 5 people. 90% of those people are right-handed. So I'd expect 4.5 out of those 5 people to be right-handed. Standard deviation is the square root of n times p times 1 minus p. So the square root of 5 times 0.9 times 0.1, whatever that is, that would be the typical deviation from the mean. That's how I'd calculate that. So that's how to calculate the mean and standard deviation of a binomial random variable. These are given to you. You don't need to